All right. This is where we left off yesterday. This is, again, 6-2. Where we're at. So one of the things you'll have to do is write a polynomial in standard form. These three are the three factors. This is the factors. The approach given here was, we talked about this a little bit yesterday, but take two of the factors and multiply them to start. So that's the FOIL process. X and x gives us the x squared. We have our 3x there. We have our 2x for our inners. And then the outers is 6, which combines the 3x and the 2x make that 5x. So if you're trying to multiply a bunch of different binomials like this or different polynomials like this, you got to use the properties of multiplication where it doesn't matter what order you multiply them, just pick two, multiply them, and then you have to multiply the last one, the x plus 1, which involves nothing but distributive property. We take the x, this x will go to each term, x times the x squared times the 5x and times the 6, and then the 1 goes to each term. You get all these things. And what you do is you start combining like terms. There's only one x to the third power. It goes there. 5x squared and x squared makes the 6. X squared, and then the 6x and the 5x makes the 11x. And then the constant is the 6. So you could take factors and go back to the polynomial form. Okay? So the expression blank is the factor form of that. That's what it says. Then yesterday we said, all right, if you had y equals x minus 5 to the third, that is the same thing as y equals x minus 5 times x minus 5 times x minus 5. Your only 0 is 5, but it has a multiplicity of 3. You'll see that terminology some on test questions and homework questions. Tell me the 0, and if any of them have a multiplicity, how much? So in this case, that one did. Now let's pick up right here. This is x plus 3 squared times x plus 1. So that is similar to this. Take these factors and write it in polynomial form. So let's do that. So we have x plus 3 squared times x plus 1. Somebody tell me, what two would you like to multiply together first? Because that's three factors there. 1, 2 here, and a third. Somebody give me, just tell me, what do you want to do an x plus 3 times an x plus 3, or do you want to do an x plus 3 times an x plus 1? This one up here first. So if we do that, that would give you x squared plus 6x plus 9. Y'all agree? And you'd still have the x plus 1. How I got that x squared plus 6x plus 9 is using FOIL. And then lastly, if you take the x times each, you would have x to the... Hello. No, she's looking for it. We're trying to have class over here. We don't know, but it's making noise. All right, let's keep going. X squared times x is x to the third. We'll just keep this x going through each. Then we have plus 6x squared. Then plus 9x. That was taking the x to each term. Then we'll do the 1. The 1 times each. It's 1x squared plus 6x plus 9. Where'd she go? Ding it again. I don't know. We don't know. Make that sound again. Oh, is that it right there? I don't know. Thank you for interrupting class. Oh, I know. It just ran off. All right, so there it is. That's it all multiplied. Does anything on that look hard, or it's just time consuming, isn't it? If we simplify that, you only have the 1x to the third plus 7x squared plus 15x plus 9. So there, that could be written in polynomial form like that. That's combining all the like terms. And 7x squared right here and here. 9x and 6x gives us the 15x. And I feel like there's always only one cubic term and only one constant when you're done. All right, so this is the opposite. Example 2 says writing a polynomial in factored form. So if you were to have a polynomial like this, factoring it is giving you the ability, if you can write out the factors, then the factors can tell you what the solutions are. So sometimes it's good to be able to factor. On this one right here, the first thing we'd factor out is a GCF. The 2x to the third, the 10x squared, and the 12x. Underline this right here. There's your GCF. 2x can come out of all of those. If you take 2x out of each term, 2x times x squared would be the 2x to the third. 2x times 5x would be 10x squared. And 2x times 6 would be 12x. So we were able to take that 2x squared, just the 2x out of all of it. That leaves this trinomial that is still factorable. And that's what you see right here. Backwards FOIL gives you x plus 2, x plus 3. 2 times 3 is the 6, and the 3x and the 2x was the 5x. So here are the factors of that polynomial. And yeah, you can check it and multiply. If these are the factors, somebody tell me, what are the zeros? There's a polynomial. We factored it. What are its zeros? What's one of the zeros? Here's your factors. You should be able to look at the factors and tell me the zeros, or the solutions, or the roots, or the intercepts. That's all the same thing. 0 is one of them. What's the next one? -2 is one of them, and -3. You put each of these equal to 0. 2x equal to 0, x is 0. X plus 2 equal to 0, x is -2. This is from x plus 3 equal to 0, x is -3. So that's how you get those zeros. If you know the factors, you know the zeros. And remember, anytime you take out a GCF like this, 2x equal to 0, well, x has to be 0 right there. Anytime you take a GCF out like that, that means there's always a solution or 0 of 0. It'll always turn out that way. Okay, one of the things you can look at, one of the things in discussion here is if you have this cubic model, this is a reflected cubic model that's been negative, you can say you got these intercepts that we talked about before. These show you the factors. And you also can talk about this dip in that rise right there. This dip can be what's known as a relative minimum. So like at -5, it looks like, is a relative minimum. And then this little hump is called a relative maximum. There's places where these cubic models, they'll want to look at those things. What's that little dip? Because that little dip might give me a clue on something I'm using it for. Or what's this little hump? That can give me a clue. Talking about humps, what's a camel with 3 humps? What do you call a camel with 3 humps? Pregnant. All right. So, example 4 says, find the zeros of a polynomial function. You should be able to tell me, if I cover all that up, somebody tell me one. We're talking about this. 2, this one is 2. What's this one? -1, and that one? -3. And it shows you that, 2, -1, -3. If you know the zeros, if you have the factors, it's real easy to get the zeros. That tells you, hey, that one's crossing at -3, -1, 2. So it could look like that. All right, turn the page. We're going to do a couple examples. Okay. what are the zeros? What are the zeros? Somebody tell me one of them. 8. What's that? Another 0. There is another 8, yes. So if there's 2 of them, you say 8, and it has a multiplicity of 2. It just means it occurred more than once. What's the other 0? 0. X is equal to 0. There. Like we said, if there's a GCF out there, it's always just 0. All right, let's try this one. That's a real easy one. If it's in factor form, the zeros are easy to find. What if you have f of x equals x to the 4th minus 8x to the 3rd plus 16x squared? What do you think I should do to start? There should be something kind of stick out to you. So, hey, well, first off, is it factored? Well, this is polynomial form. It's a quartic trinomial. So I can look, hey, I can look at it on a graph. I can factor it. Does anybody see how it's factorable here? Yes. Let's do a GCF. Let's bring an x squared out. If I bring an x squared out, I would end up with x squared minus 8x plus 16. Does that trinomial factor? Oh, it's minus 4, isn't it? Perfect square trinomial. So, how many possible zeros does this have? Look at your honest degree there. How many zeros could it have? 4. Your degree tells you how many it could have, possible real zeros. And so, it has 4. It has 0 right here. So it's 0 with a multiplicity of 2. What else do we have? 4. How many times does 4 occur? 2. So 0 happens twice and 4 happens twice. So what would that look like? If we wanted to look at that on a graph, we would say x raised to the 4th minus, no, I don't want to be there, minus 8x to the 3rd plus 16x squared. All right, so there is that. We talked about these quadratic or the quartic. This thing is going to go forever up this way. It's coming down. It turns. Right up here will be a relative max. If I zoom out, let me zoom out so you can see that. Put the center right about there. There we go. So now you can see this line will forever go up, comes, turns, relative max, there's a relative minimum, relative max, another minimum, and it forever goes up. So remember, anytime you have a polynomial to the 4th power, that's an even degree, your terminal ends will be going the same direction. We talked about that yesterday, didn't we? And you notice it could have potentially, this thing could have potentially came down, crossed the x-axis once, twice, came up, come back down, crossed it once, twice more, but it didn't cross it 4 times because both of these minimums right here were sitting directly on the x-axis, so it gave 0 a multiplicity of 2, and it gave 4 a multiplicity of 2. Okay? That's what it looks like if you were to visualize it. Right here and here. Relative. Oop, went on. It's a good question. Okay. So knowing the multiplicity, you got to be able to see the factors to know the multiplicity on that deal. Let's see here. We will do the homework answers always too. I'll do the video of the notes if we have notes to video, and then when I show you the answers, I'll make a video out of it also. That'll be good for you guys if you ever got to go back and check when you get ready for your test. And we're going to say this. Hi, Logan. Hopefully he is doing well. Hopefully you're doing well when you get to watch this. He's probably won't get to watch this for a day or two because I think he's having surgery today or something like that. Either way. All right, we'll stop right there. I'm going to give you your worksheet.